Welcome to Brain Vision.
For this question, we're told that we have a 20-meter long copper wire. So L is the length of the copper wire, little l, and it has a diameter, little d, of 2.0 millimeters or 2.0 times 10 to the minus third meters. It's wrapped around in single layers around in a coiling manner to form a solenoid of a diameter big D of 2.5 centimeters or 2.5 times 10 to the minus 2 meters. What is the length of the solenoid using this information? So to find the length of the solenoid using this information, for part A, we simply use the equation that says the length of the solenoid L, big L, is equal to the diameter of the wire, the copper wire, D, times the length of the copper wire, L, divided by pi times the difference between the diameter of the solenoid, big D, minus the diameter of the copper wire, little d. Plugging those values into this equation, we find that the length of the solenoid is 0.554 meters. And we can box that in as our solution for part A. Part B says, what is the field at the center if the current is I and it's equal to 16.7 amperes? Okay, so first we need to find the number of turns per unit length, and then we can use that to find the magnetic field. So the number of turns per unit length, N, is by definition equal to the ratio of the length of the copper wire divided by pi times the difference in the distance, D, the big diameter of the solenoid divided by the diameter of the copper wire, or minus the diameter of the copper wire. And then all of this is divided by the length of the solenoid because it's per unit length of the solenoid. So the top value gives us the number of turns and the bottom value gives us per unit length of the solenoid. So what this comes out to equal is 500 turns per meter, or 500 turns per unit length. So now, if we go back to calculate the magnetic field B is simply mu naught times N times the current I. Mu naught is the magnetic permeability of free space. It's 4 pi times 10 to the minus 7 newtons per ampere. So plugging those in, we find that this is equal to 10.5 times 10 to the minus 3 Tesla, or 10.5 millitesla. And we can box that in as our solution for part B.